Okay, now we are going to focus on the various topics like angle of crossing, various types of turnout, stations and yards. So first look at the angle of crossing. Angle between gauge faces of point rail and splice rail is known as angle of crossing. There are three methods to set the crossing angle. The first method is the right angle method, which is also known as the Cole's method, centerline method, and isosceles method. As far as the right angle method is concerned, this method is being used in Pakistan and the India. Centerline method is quite common in USA and UK, and isosceles method is being used in different countries. Now on this particular slide you would find two numericals. Find out the values of crossing angles for 1 in 12 by using all three methods. And the second problem is to find out the values of crossing angles for 1 in 8.5 by using all the three methods. Now look at this problem, a solution of the problem where the size of the crossing is 1 in 8.5. So 1 in 8.5, so this is the capital X. So X is 8.5 feet. So X can be taken as capital N because in some books you would find symbol N for this capital X. Okay, now look at the right angle method. In right angle method, the idea is that we are considering a right angle triangle when you are considering the V piece. And you can see that this distance is X, this angle is alpha, and the spread between the two rails, that is equal to 1 foot. Okay, tangent alpha obviously equal to 1 over x. So x is equal to 1 over tangent alpha. So x is equal to cot alpha. And if you just plug in the x value, you could be able to get the alpha. That is the crossing angle, that is 6 degree 42 minute 35 seconds. And if we look at the centerline method, in centerline method we are considering the spread of 1 foot again, and you can see that there is one centerline that is being considered. This angle is alpha, so obviously this is alpha by 2 and this is alpha by 2, and this distance would be 1 by 0.5 foot, this would be 0.5 foot, and this is the distance x which is being measured along the center line. Now here tangent alpha by 2 obviously equal to 1 by 2 over x, and then you can say capital X is equal to 1 by 2 over tangent alpha by 2, and then x is equal to 0.5 times cot alpha by 2. So putting x is equal to 8.5, you can get the alpha, that is the crossing angle, equal to 6 degree 43 minute 59 second. Isosceles method, we are considering isosceles triangle in which at least two sides are equal. So this side is and this side both are equal, and look at that, the distance x is measured along this particular side. This is x, so this distance is also x. So the spread between the two rails, that is 1 foot. So obviously this is 1 by 2 foot, this is 1 by 2 foot. So this angle is alpha by 2, this is angle of alpha by 2, and this total angle is alpha. So here using the trigonometric identity of sine alpha by 2, that is equal to 1 by 2 over x. So x is equal to 1 by 2 over sine alpha by 2, and then you may write x is equal to 0.5 times cosecant alpha by 2, and when you will put x is equal to 8.5 feet, so you are getting the alpha value 6 degree 44 minutes and 41 seconds. So you can see that in all these methods you are having almost the same value of alpha. So keep this thing in the mind that when you are considering the 1 foot spread, that is the spread that you are having between the point rail and the splice rail. So point rail and splice rail. So one of the two rail, one is the point rail, the other is the splice rail. Okay, switch. Switch, is the combination of stalk rail and tongue rail. The distance between stalk rail and tongue rail at the heel of switch is heel divergence. Its value depends upon flange clearance and width of rail head. The value of switch angle depends on heel divergence and length of tongue. For broad gauge, heel divergence varies from 5 and 1 by 4 inch to 5 and 3 by 8 inches. So here you can see this is the heel divergence. So you can see here the tongue rail, the stalk rail, and you can see the stretcher bar which has connected the two tongue rails. And this is the heel of the crossing. So this distance is the heel divergence. Length of switch. Well, length of the switch can be related to the crossing size, and for the crossing size of 1 inch 16, minimum length of the switch is 32 feet. For 1 in 12, crossing size 21 feet, and 1 in 8.5, 15.5 feet. So keeping this thing in the mind that when you are having a larger number in the crossing size, so it means you could be able to maintain high speed. Types of switches based on shape: undercut switch, straight cut switch, overriding switch. First, look at the undercut switch. The tongue rail at the toe of the switch is planed so that the toe is accommodated under the head of the stalk rail. In modified section, half web of the tongue rail is below the head of the stalk rail and the width of the top of tongue rail is increased. This modification reduces the splitting tendency of the tongue rail. So this is the typical undercut switch. So you can see that this is the stalk rail and this is the tongue rail. And here you can see this is the modified undercut switch. So you can see that here the shape of the tongue rail is like this. So it is adjusting just over here like this. Straight cut switch. The tongue rail is kept slightly in line with the stalk rail. This is usually provided for bull-headed rails. Overriding switch. The tongue rail slides over the foot of the stalk rail. Now on this particular slide you can see here, this is the undercut switch. I have already shown this one. This is the modified form of the undercut switch, and look at that, this is the straight cut switch. Look at this. This is the straight cut switch, and here the overriding switch, you can see that we are having a packed piece and the tongue rail is moving over the packed piece and the foot of the stalk rail. So this arrangement is called as the overriding switch. Various types of turnouts: double turnout, diamond crossing, symmetrical split, crossover, gathering lines, gauntlet track, temporary diversion. So double turnout. This is also known as tandem. Sometimes we use the word tandem for the double turnout. Two turnouts take off from the main track. So look at that. This is the main track and the two turnouts are there. This one and this one. Diamond crossing. When two tracks of same gauge or different gauges cross each other in such a manner that two angles are acute and two angles are obtuse. So you can see that this track is and this track both are crossing over here. So this arrangement is called as the diamond crossing, but two angles are acute less than 90 degrees and the two angles are more than 90 degrees. This is another arrangement of the diamond crossing, that this track is crossing this track, but this you can see the curve tracks have been laid, so the train can be moved from this track to this part of the track. Symmetrical split. This is also known as equivalent turnout. If two similar turnouts are taken out from the straight track in two different directions, such a junction is known as symmetrical split. So here look at that. This is the track and then you are having the splitting of the track this way and this way. This is called as the symmetrical split. Crossover. Transfer of a train from one continuous track to another continuous track. The track may or may not be parallel to each other. Crossover consists of two sets of points and crossings. So here you can see one track is this one, the other is this one, and you are having this link. Here two parallel tracks and you are having this arrangement, and this one the two tracks are far, having the quite large distance, and we have connected these two tracks with this relatively longer track. Scissors crossover. This is also known as double crossover. This track junction enables trains from opposite direction to change the track. If the space is insufficient, scissor crossover is used. So look at this arrangement. This is one track, this is this one, and we are having the arrangement of this and this. So this arrangement is called as the scissors crossover. Gathering lines. When a number of parallel lines are connected together with the main track, the connecting lines are called as gathering lines, also known as ladder track. So here look at this one. This is the original track, and you can see different loop tracks have been connected to the main original track. Same thing you can see over here on an exaggerated scale. We are having loop 3, 2, 1, and these have been connected to the original main track. So this arrangement is called as the ladder track or the gathering lines. Gauntlet track. The track, which essentially is superimposition of one track over another. When two lines of different gauges are required to cross a common bridge, in this case three rails are laid for the two tracks. One rail is common to both of them. This arrangement saves the cost of an extra bridge. So look at this arrangement. Here we have accommodated two types of tracks, broad gauge and the meter gauge, and you can see that this rail is common for the both track. Temporary diversion. Whenever certain stretch of the track has to be closed for one reason or the other, the traffic is diverted by providing a temporary diversion. So look at this. This is the original main track, and this is the diversion. And you can see that in this way you can correct this diversion. You can have the temporary diversion of this, that you are having this track, you are having this track, and we are having the diversion like this. Okay, now we have reached here, that is the topic of stations and yards. Station means any place on a railway line where traffic is batched, authority to proceed is given to trains, movement of the train is controlled to avoid accidents. Requirements of railway station. The general features for a railway station can be classified into following categories: general, public, traffic, locomotive. Well, the general requirements: suitable approach, roads to station, offices for the staff. As far as the public requirements are concerned, waiting room, mosque, booking office, platform, sentry arrangement, water supply, restaurants, telephone, parking. Traffic requirements: signals, sidings or side loops, locomotives, watering, fueling, inspection and repair, arrangement to change the direction of locomotive. Layout of single line station. Single line station has one main running track, but additional loops or sidings are provided for the crossing of trains or for the parking of goods trains. Turnouts are used to divert the trains from one line to the other line. Keep this in the mind: when we use the word line, it means track. Now this is one type of the layout of single line railway station. So you can see that this is the main track, and look at that, here it is written up and this is down. That means as far as the elevation is concerned, if the train is moving in this direction, so you are going in the upward direction slightly, and here if the train is moving in this way, so you are coming in the downward direction. So just in the sense of elevation, the wording up and down are written in this figure. So look at that, this is the main line, we are having the passenger platform, station building, and you can see that the loop lines are there, and this is meant for the goods train, so the good platform is also present. Layout of double line station. In this case, two main running tracks are there. Crossovers are provided between the two main tracks. Advantage of double line station. If the two trains are running in the same direction, then the fast moving train can pass the slow moving train without any disturbance. And look at this arrangement. There are several possibilities, but here one layout is given. So you can see here that there are two main lines, this one and this one, and you can see here main platform is this, station building can be seen, and this arrangement or this part is for the goods train, so goods platform and the shed is there. and you can see that a branch line is originating from this main track in this way, and you can see the turntable is also provided, and there is another platform is provided over here, and that has been linked to a bridge. So this is the layout of double line station. Junction. I'm sure you have heard this word junction. Junction is the station where a branch line track meets the main line or any other combination. Special arrangements are made for interchanging of traffic between the branch line and the main line. Terminal. Terminal is a station at which the railway line or one of its branches terminate or ends. So dead end or buffer stop. It is provided where the track ends. Buffer is a spring-loaded device which absorbs the shocks in case the train touches it. Now look at the terminal over here, terminal station. So you can see in this particular case there are 4 tracks which are ending over here. Look at that. And hydraulic buffers have been installed over here, and you can see that we are having the checking space, circulating area, we are having the station building over here. So this arrangement is basically considered as the terminal. So dead end or buffer stop, it is provided where the track ends. Buffer is a spring-loaded device which absorbs the shocks in case the train touches it. So look at that, buffer stops. There is another arrangement which can be provided at the end of the track, that is the dead end. At the end of the track, this type of the structure can be placed. But this arrangement is used for the less important railway stations. For important railway stations, we use the hydraulic buffers. Platform. Two categories: passengers platform, goods platform. Passenger platform. Minimum width is equal to 12 feet. The width varies, but minimum is 12 feet, beyond which buildings are constructed. The length should not be less than the longest passenger's train. In Pakistan, length is from 600 to 1000 feet. Minimum height above the rail level is 2.5 feet to 2.75 feet. Goods platform, obviously the platform meant for the goods trains. Height of the goods platform is more than the height of the passenger platform. Normally the top of goods platform is flushed with the floor level of the goods wagon so that bulky articles can easily be loaded and unloaded in the wagons easily. Now, yards. We are going to discuss the yards. So yard is the network of tracks laid within definite limits for sorting of vehicles and making up of trains. Yards are usually laid on level ground, as gradient in case of yards is not desirable. Normally 1 in 1000, and in difficult situation 1 in 400. Layout of the yard depends upon passengers traffic and goods traffic, that is the type of the traffic. So here you can see that this is the yard. This is the railway station basically, and different yards are there. So, the yard is the network of tracks laid within definite limits for sorting of vehicles and making up of trains. The railway yards are divided into following categories: passenger yard, goods yard, marshalling yard, locomotive yard. Marshalling yards are provided on the important railway stations. Passenger yard. The function of the passenger yard is to provide facility for the movement of passengers and vehicles meant for the passengers. Goods yard. A goods yard has to cater for the receipt, loading, unloading, and delivery of goods and movement of goods vehicles. Here the vehicle means the train. This portion includes facility for goods traffic, loop lines, goods shed, and machinery for loading and unloading of the bulky items. Then comes the locomotive yard. It is the space where facilities have to be provided for the stabling and servicing of locomotives. The loco yard contains a number of tracks leading engine to shed, inspection pits, repair pits, turntable, repair shed, water columns for filling water, etc. Marshalling yard. Marshalling yard are used for the sorting of goods vehicles and to arrange the wagons in order of their destination. Marshalling yards are the distributing centers, you can say. Empty wagons are also kept in marshalling yard and dispatched to different stations as and when required. So, design requirements for marshalling yard. Marshalling yard should be designed in such a manner that shunting operation does not disturb the schedule of the regular trains. It should be located parallel to the main line. Marshalling yard should be designed in such a way that the maximum number of wagons can be dispatched to their destination in short time. Movement of vehicles should be preferably in one direction so that process will be easier and conflicts are the minimum. Necessary repair facilities should be provided in the marshalling yard. Now, the layout of marshalling yard. So there are three important parts: reception siding, sorting siding, and the departure siding. First, look at the reception siding. These are the sidings where the incoming goods vehicles are received and wait for their turn for shunting operation. The shape of reception sidings are in the form of a grid and their lengths are kept normally equal. Sorting siding. These are the sidings where shunting operation is carried out. From reception siding, trains go to the sorting siding. Each track of the siding is allotted to wagons bound for one particular destination. Their number depends on the number of destination or group of stations to which wagons have to be dispatched. And then departure siding. Keep this in the mind that departure sidings are optional. In some cases, departure sidings are provided. In some cases, these sidings are not provided. So departure sidings are optional. These would depend upon the intensity on the main track. If the main track is frequently busy, then departure siding should be provided. It is also in the form of grid as the reception siding. So look at here. You can see that this is the main track. So this is the part, you can treat it as the reception siding. From reception siding, the wagons will be sent to the sorting siding. Here the proper shunting will be carried out, and after preparing the train according to their destination, by using the departure siding, those trains will come to the main track. So reception siding, sorting siding, and the departure siding. These are the three, you can say, main components of the marshalling yard. Okay, yards based on topography. Depending upon the topography, marshalling yards are of following types: flat yard, gravitational yard, hump yard. So flat yard. In flat yards, all movements of the wagons are carried out with the help of engines or the locomotives. Such yards are only justified where the space is limited. Gravitational yard. In gravitational yard, the tracks are laid at suitable gradient and the wagons are moved under gravity influence. The movement is controlled by the wagon brakes. This is ideal type of marshalling yard, but it is handicapped due to the topography of the area. Hump yard. A hump yard is one in which the wagons are pushed up to the summit, that is the highest point, by an engine and moved down on the opposite slopes into various sidings under the influence of gravity. So this slide is showing the hump yard. So you can see that this is wagons are pushed to this hump or the summit, and then from here, under the influence of gravity, the wagons can be sent into different sidings. So this is the hump yard. So in this while we focused on the angle of crossing, and we discussed the three different techniques to determine the angle of crossing. We discussed the various types of turnouts, and we discussed the stations and the yards. So thank you.